Good afternoon, everyone. My voice is audible.
Yes, sir, audio. Good afternoon.
Okay, fine. So today we are going to see how to create machine learning model. I mean, only if you have real-time data, then how we are going to create some kind of predictive model on that. And further, we will see how to create a Windows app using MATLAB. Okay. So let me give a brief that about MATLAB again, that what you can do with MATLAB. So MATLAB is a high level language like mathematical equations which you write in your notebook as it is you have to write in a MATLAB. Plus two things are very important in MATLAB, that you have to know what you can do with MATLAB and how you can get help with MATLAB. So already we discussed and we saw that how to get in MATLAB in first session, right? You can interface more than thousands of hardwares and more than 130 hardware vendors are supported with MATLAB. You can integrate MATLAB into your production analytics applications also. Means each and every functions of MATLAB are tested thousands of times by MathWorks engineers. So you need not to worry about MATLAB functions here. So either you can integrate with production analytics application or you can launch it commercially also for that. You can integrate MATLAB code with other languages also like C, C++, Java, .NET, Python. So there you have a MATLAB compiler SDK toolbox in MATLAB. You can use that toolbox to generate library for other languages also like C, C++, Java, .NET, .com, Python, and you can interface with that languages also. Let's say that if you are working on big data or if you have so many iterations in your algorithm, and if it is taking so much time, then you can iterate your iterations on clusters also and on clouds also. You have a MATLAB parallel server and parallel computing toolbox. Let's say that in your single machine, if you have 4 cores and if you are using parallel computing, then at a time you can open 4 MATLAB. And if you have clusters with thousands of cores, so at a time you can open thousands of MATLAB and it will run in a background. So whatever for loop you are giving and whatever other iterations you have, you can iterate your iterations on clusters and clouds also. You can plug into Simulink and Stateflow for simulation. So we saw Simulink, how to design a model on Simulink, and Stateflow is used for advanced controller designing. So Stateflow is a graphical way how you are going to design the controller. Apart from that, you can convert MATLAB code in other languages also like embedded C, CUDA and HDL code. There are PLC coder, there is PLC coder available also. So you can in a single click you can generate other languages also. You can generate HDL, C, C++, embedded C. Okay. This is our agenda for today. Log live data to MATLAB. So yesterday we saw that how to log live data in MATLAB. We are going to see it again, and plus machine learning model on live data. How we are going to create machine learning on live data. Further, we are going to see overview on digital twin, how digital twin works and what is digital twin and how industries are using digital twin for predictive maintenance. Okay. Further, we will see app designing with MATLAB. App designing means design the app and create a .exe file. Both we are going to see together. So first of all, I will start the case. We will discuss first of all what is digital twin, and I will start from case study about Tata. So you know everyone is aware about Tata, right? So the Tata Steel Group, I am talking about Tata Steel Group. They use the MATLAB and they optimize their controller and they save 40% energy on cooling towers. So they have a Tata Steel Group is among the top global steel companies with an annual crude steel capacity of 27.5 million tons per annum. And Tata Steel Group is geographically diversified steel producer within 26 countries, and commercial presence of Tata Steel Group is in 50 countries. So when they manufacture steel, they require some kind of cooling fans, cooling towers for that, because lots of heats are produced, so they require to cool that tower. Okay, so they have 200 cooling towers they use to cool that plant. So they are medium and high capacity cooling towers, means as high as 1000 tons of refrigeration. So you can see that how big capacity it is. What challenges they were facing? Dr. Sarkar, who is from this group, he told that if we can reduce the energy consumption of the pump and the cooling fan, then energy will be saved significantly. To do that, we have to install the variable frequency drive instead of the control valve. So before they were using control valve actually. Let's say that I have this kind of plant and I have 10 fan to cool that. Maybe sometimes I require 5 fans only, but because of control valves 10 fans are on. So I don't require remaining 5 fans to on at that time. So that are what? That are loss of energy, right? If I require 5 fans, 10 fans are on. If I require 10 fans, then 2 fans are on only. So manually doing these things is not optimized, right? So they require to optimize this. So what they did basically, they created a digital twin of it. What is digital twin? Means a replica of original plant in Simulink. A replica of original plant in Simulink means they created a virtual, same real plant they created virtually on Simulink. They log data from sensors from the real plant. Okay, they log that data sensor from sensors. They created some kind of predictive model like machine learning, or you may also they use optimization to optimize that variable frequency driver. So you see what is happening. There is one real plant and another is virtual same plant on Simulink. They log that data from real plant. They predicted and they do some kind of analysis what will be a future behavior of the plant using virtual. On real you can't do this kind of task, so that's why they created. And further they optimize that variable frequency drive. So after optimizing, they were the efficiency was increased. So here you can say they save the 40% energy on the using the digital twin, right? So what is digital twin now? A digital twin is an up-to-date representation, a model of an actual physical asset in operation. As I told, you have an original model, means original plant, and you are going to create virtually in Simulink. That is called digital twin. And further, it reflects the current asset condition and includes relevant historical data about the asset. So you are logging live data from the sensors from the let's say if you have a machine, it and what can be a sensors you can apply on machines. Let's say you have machines and motors, that can be RPM of it, right? There will be some other parameters also which you can extract from sensor data, speed, RPM and all these things, right? So further that data they use to do some kind of predictive analysis on virtual plant, and they predict the behavior of the plant in the future, that what will be a behavior of the plant in the future. Based on that they optimize their plant. So virtually they got, then they apply on physical system. So these are the process which you have to follow. You see this, let's say this is a digital system, this is a physical system. They are synchronized, they are bi-directional. Data is coming to digital and then it is going to physical. So these are the some applications, I mean, which you can extract from digital twin, like system 3D visualization, system data integration, intelligent decision making, applying on virtual, what next decision are you going to take, system optimization operation, like in the case of Tata Steel, they optimize the variable frequency driver to on the cooling towers whenever it is required. Apart from that, you digital twin you can use system health monitoring as well. So how digital twin works in Simulink using MATLAB, right? So there are some, we have some libraries available in Simulink, like electrical component. Let's say if you have electrical plant, so you can use electrical libraries from Simulink. If you are working on translational or rotational kind of models or vehicles kind of things, so for that we have library driveline. If you are working on mechanical plant, we have library available to design that plant virtually. Multi-body, someone is, if you have plant on mechatronics, or if you are working on 3D, if you want to design the 3D model of your plant, so you can use libraries from multi-body as well. Okay. And someone is working on fluid dynamics, if you have fluid kind like petrol pump, if I am talking, that is based on the fluid, right? So that kind of plants, if you have, we have libraries for that to design that original plant virtually in Simulink. And further, data driven modeling, that is deep learning, machine learning, to predict the behavior, to predict the response of your system in future. In present time, you can predict in real time as well as in future that what will be going to happen with your plant. Okay, so all these things you can do. So we are going to cover this one, because right now I can't show any real physical model. So we are going to discuss about this, how to create a forecastive or predictive kind of model using machine learning. Okay. So first of all, some applications of digital twin you see here, like operation optimization. In the case of fan, is like if you have to optimize the fan speed, or if you have to optimize the cooling towers, so you can use digital twin operational optimization. Predictive maintenance. Predictive maintenance is very useful and very widely it is used nowadays, because using predictive maintenance, you can predict that which component is going to stop in the future. Let's say you know that all Indian electricity power is connected from one office. Everything is, it can be, except that 7 sisters, all other states are connected from central office. So if something will happen at central office, then complete power shutdown will be happened all over the India. And it happened around in 2008 or 2009 one time. So why this happened? Because that time we didn't have advanced technology like predictive maintenance kind of things. Now we have machine learning, deep learning. We can use to forecast that when my system is going to shut down. And how will you forecast? Let's say you are measuring the RPM. Good RPM is coming, but what after 2-3 days you saw some changes in the RPM. So you will identify that now RPM is changed, means something is going to happen in the future. So you can change your motor, right? Anomaly detection means sudden detection kind of things. Let's say you have a complete transmission line and there is some kind of sudden detection, issues, some faults are available there. So you can detect anomaly detection also using this digital twin and Internet of Things. Fault isolation. Let's say you have some sensors, if you install like speed sensor, throttle sensor, depends on the plant that what kind of sensor data you have. You can visualize that, you can do machine learning on that, and further you can predict that if there are some kind of fault data or not. So like it is like identifying the pattern in the data. Based on the pattern you can say that okay, this faulty data is coming, I require to isolate this component. That is very important, right? So this kind of application nowadays industries are using. If you heard about industry 4, so they use digital twin, IoT and industrial IoT, industrial data analytics. So the data analytics which we do, that is a different, and the industrial data analytics is different actually. So machine learning is a part of our data analytics. Okay. So how digital twins work again? So what components we require? Smart assets from where you can control it. Edge system means sensors. Smart asset means you can deploy the sensors and you can log data from there. OT systems means OT system includes cloud also, means where are you going to upload your data, and the IT system to manage everything, means to create some kind of machine and learning model or deep learning model to predict the behavior of the system. So all these 4 components you can design in MATLAB very easily. You have a ThinkSpeak, you have a MATLAB as a IT system, you can interface hardwares, you can log sensors data in MATLAB, right? Okay, that was about digital twin. Now about machine learning, which we are going to see. Okay, so these are some applications of machine learning, like speech recognition or natural language recognition. So if you have to recognize the speech, that if a person is like if a person is saying hi, bye, or something like that, or if you have to detect the emotion based on the speech, that if a person is angry or he is laughing, what kind of emotions he has, right, he or she has. So this kind of detection you can do. Object recognition, let's say if you have to track something live, so you can use, and you know that deep learning and machine learning is used to detection some kind of different behaviors, like if you have to track someone, that if a person is a terrorist or thief or something like that, based on the motions, that what is the gesture or that on the face of that person, based on that you can detect, or based on the behavior, how he is behaving, abnormal or normal kind of things. So their machine and deep learning both are very widely used. We discussed about engine health monitoring. You can use machine learning in weather forecasting also. So the forecast which you see on Google or on some application, that after 10 days temperature will be this, or it will be rain or not. So that are applications of machine and deep learning. Okay. Energy load forecasting, stock market prediction. Let's say you want to know that where you have to put some money on stock market, right? So that kind of predictions also you can do. IoT analytics, so we can't imagine IoT without data, without machine learning then, and without deep learning. Taxi availability kind of things, air flight delays, that is very important in some cities of world. If there is a delay, if I am not able to predict the accurate delay, maybe 2 flight can be kept, because they are very busy platforms. So I have to I have to forecast the exact delay, that what will be a delay between 2 flights. Okay, that is very important. Okay, this is a machine learning case study. Everyone heard about Mahindra. Also previously I told that Mahindra and Tata Indian company, they use MATLAB in some parts. Many companies use. Just I took a case study. If you visit on MathWork website, you can get many case study from companies. So what Mahindra had done, they modeled a road condition estimator using machine learning. Okay, so what are challenges right now if I am talking about road conditions? So road surfaces and condition is a critical parameter for vehicle operation, right? Why road surface and conditions are critical parameter for vehicle operation? Let's say if you are traveling on mountains, hill areas, your driving style will be different, right? And your vehicle operation will be also different. So they have to optimize their vehicles to design a vehicle in a such way so you can drive in a plain area also, you can drive in a mountain and hills areas also. Diversified categories of road with different terrain combinations. Of course, surfaces are also different, not only hill area or plain area. Somewhere, some places there are good roads, some places there are bad roads also, right? So these are the challenges in India. If I am talking about that, roads in India, roads are divided as a class A, class B, class C. Class A are good roads, class B are some medium, you may say. Like these categories are there of roads also. Also it depends on terrain changes, need a change in driving style also, right? As I told that if you are driving in a plain area, then your driving style will be different. If you are driving on hill area, then your driving style will be different, right? So these are the problems right now. So how to sort out these problems, what Mahindra engineers did for that? So first of all, using a road condition estimator, what they can predict: tire life and wear. Means what will be a tire life it is driving in this kind of roads or in this kind of area, right? Vehicle durability and aging impact, that what will be a durability of the vehicle, what will be a aging impact using this road condition estimator. Fuel economy impact also your fuel economy depends if you are traveling in the city or if you are traveling on the highway, or if you are traveling on the mountain or in the plain area, your fuel economy will be different. Fuel economy is what? Kilometer per liter. That is the fuel economy. Okay. So what they have done, they collected images of good and bad roads like this. Okay. So further, finally, what they did, they classified this images. This is a good road and this is a bad road. And what the process they followed for that, in MATLAB, they collected and labeled the data. Of course, whatever images you have to label that this is a good road, this is a bad road. Then only you are going to classify that data, right? Pre-process on data, they pre-process then extract the features. So in machine learning, not only you require a raw image, you require some kind of pre-processing. Further, you require to extract the features. Means this is a good road, then what features can be in that? Like edges can be. Here you will see different edges will be there. In this image, the edges will be different. So these are the features which they require to create a machine learning model for that. Further, they optimize that model for the high efficiency, and next they deployed that model in a Simulink. Why they deployed that model in a Simulink? To deploy again in a hardware. So Simulink is the easiest way that you can deploy your model in any kind of hardware. Okay, so in Simulink, code generation and deploying is very easy. For the real-time applications, they deployed that model on hardware. These are some other case studies in MATLAB using machine learning. You know BMW company, right? There is an automotive company. They use for some kind of applications like detecting oversteering and machine learning. Okay, with machine learning. Mercedes also, you know about this company also. They use predictive maintenance toolbox from MATLAB to recognize the pattern from time series data. Honda City also, you are aware about that. ASML is a semiconductor company. So these are companies, they use machine learning for their some applications. Okay, then what is the machine learning? We discussed applications. Now what is machine learning? Machine learning teaches computers to do what comes naturally to humans and animals, learn from experience. So you may say the things human and animals can do, same facilities we are going to give to machine. That machine will do for us. Okay, the things which we can do, machine will do for us. A machine is here. If I am saying machine, means algorithm, not AI. I am not talking about AI. AI is an advanced. If I am saying AI, means I am acting like a human. Artificial intelligence who is acting like a human. But here I am talking about machine learning. That is an algorithm. This is a part of AI. This is the way. This is the binding between human and machine. Connector, you may say. Okay. So machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So what it means, for machine learning, to create a machine learning model, we don't require any kind of predetermined equations. Okay. Before which we saw polyfit or different kind of, if you are creating mathematical equations that are static, they are fixed. You can't modify that mathematical equation. But in machine learning, if new trend will come, if new demand will come, based on that, machine learning model will be optimized automatically. Let's say that whatever we are wearing clothes today, maybe after 1 year new trend will come. So data are changing. When data are changing, you mathematical equation will not work there. If data is not changing, then you can go for mathematical equation. Otherwise, you have to go for machine learning. Like energy demand, load demand. Every day something manufacturing are going on, right? And every day demands are increasing. So demands are increasing, so we require a adaptive model. I mean, which can adapt based on the demand data, and it can forecast that what will be a demand in next year or next month. Okay, the algorithms adaptively improve their performance as the number of samples available for learning increases. As much as number of samples will increase, performance will also increase in machine learning. Okay. So how machine learning works? So it depends on you that what do you want from data. What insights are available in data and what insights do you want, means what output do you want from that. So based on that, machine learning is divided in two parts, that is unsupervised learning and supervised learning. Unsupervised learning example is clustering and supervised classification and regression. Now what is clustering? Let's say you have a supervisor, or you may say your HOD. Let's say your HOD is telling you that go in the market and collect the data and I will give you a result on that. So that is a supervised learning. Means you are collecting input from the market as your HOD told, and HOD is telling that what will be a output on that data. That is a supervised learning. But in clustering, let's say you after engineering, the engineering which you are doing, you don't have any HOD, you don't have any guide, let's say something. So everything you are doing alone. You don't have any supervisor, just you are collecting data and identifying the pattern in that. So what it means, in clustering you have just data, not any kind of outputs. Outputs you have to find out from the data. In supervised learning you have inputs and outputs both. When we use data in supervised learning, we require input and outputs both. In clustering, no, just a data. So clustering example is what? When you capture images from your mobile, your images are clustered automatically as a name, as a place, right? Or something, when you search on Google, let's say I'm searching something MATLAB, so I will get the links of MATLAB only, right? That is an example of clustering. Just I'm giving the input and I'm getting cluster of that, right? So many examples are there, like some examples about Netflix, that you are watching some movie or you are watching some movie on Prime or YouTube. They recommend you, okay, you watch this, then what will you watch the next? That is a clustering examples of that. So in supervised learning, classification and regression. What is classification? Classification is a discrete learning, regression is a continuous learning. In classification, we divide data as a classes. Like let's say if I have to create a predictive model for temperature as a class. So what will I do? I will take some set of data, let's say from 3 degree to 10 degree low, 10 to 20 medium, 20 to 40 normal, 40 to 60 high. I will give the class name for that, low, high, medium. So that's why it is called discrete learning. Regression, any mathematical equation which you create, that is a regression. Okay. From data, if you are going to create any mathematical equation, that is regression. Means for every input you are getting the numeric data. That is a regression. Example of regression is like, let's say I have to do load forecasting. I know what is the humid today. I know what is the temperature today. I know what is the wind energy today. Based on that, I can predict that what will be a load in this environment. Of course, if there is so much hot, so many ACs will be on, right? If it is winter, then heater will be on. If it is somewhere October or November, neither heater, neither AC will be on. So load will be less, right? So if I know the inputs, I can predict numeric value that what will be a load in kilowatt hour, right? So this kind of learning are called regression. So how do you decide which algorithm to use? First of all, there is no best fit or one size fits all. Means there is not a single machine learning model algorithm which can be fitted to all data. There is not a single algorithm which can be fitted to all data. So first of all, based on your data, you have to select the algorithm of machine learning that which will be your best. Finding the right algorithm is partly just trial and error. Even highly experienced data scientists can't tell whether an algorithm will work without trying it out or not. Means even if there is a highly experienced data scientist, even he or she can't tell that which algorithm will be based on your data. They have to hit and try kind of things they have to do. As I told that machine learning model also depends that types of data you are working with, the insights you want to get from the data, and how those insights will be used. This also depends, like what insights do you want? Are you going to use regression? Are you going to use classification? or some just pattern recognition are you going to do, or you are going to do clustering, depends on that your algorithm will be changed. Here these are the algorithms for that. So question is that how to choose the best algorithm for your data, if you are using classification or if you are using regression or clustering. Okay, so these are the algorithms. So what you have to do, if you are working on machine learning, you have to learn all this algorithm to get that insight from that algorithm, that where you can apply. That is very important. If any software if you are using, you require to know all these algorithms. Like if I am talking about this nearest neighbor, so nearest neighbor works on a same kind of data, class which I told, character, category, numeric value. So if all data are character, then good. If there are mixed data, numeric value also and character also, then KNN will not work. Right? So these things you have to know, that algorithms, you have to know how algorithms work, right? And you see that some algorithms are there in classification which will not work in regression. That is very important. So when should you use machine learning? You have mathematical model, you have fuzzy logic, you have a neural network, you have a deep learning. Then why are you going to choose machine learning? That is a big question. That I can create mathematical equation, I can use fuzzy logic. Why should I use machine learning then? See, fuzzy logic, when you if you know about fuzzy logic, so fuzzy logic is used when you don't have data. Fuzzy logic is based on your reasoning, based on your logic. Let's say I am a farmer, so I know if I am a farmer, I can predict that when rain will come. So okay, what will I do? Let's say I am a farmer, I will say okay, temperature will be around this at 1 p.m. and in the summer, in May, temperature will be this, okay, humid will be this, then there is a possibility of rain or there is no possibility of rain. We make the rules just on the assumptions, just on the reasoning. If you don't have data, then you can go for the fuzzy logic. Okay, but if nature of data is not changing and you want to create a predictive model, you can use mathematical equations. But if nature of data keeps changing and it is not easy to create a mathematical equation, go for the machine learning. Now let's say if you have as much as big data that you cannot extract the features from that, thousands and millions of rows and columns you have in your data, go for the deep learning, because in deep learning we don't require to extract the features from that. So depends that what kind of data you have. So here handwritten rules and equations are too complex. If I have to predict handwritten rules and for that, not possible to create a mathematical equation. It will take so long time to predict the handwritten equation, rules or equations or alphabets, you may say. As in face recognition or speech recognition, if I have to recognize the face from the body, so how you are going to create a mathematical equation? That is very complicated. It can take 1 year or 2 years to create a mathematical equation, and based on that you can predict the face, right? Others, the rule of talks are constantly changing, as in fraud detection or transaction records, from transaction records. So fraud detection can be from internet, fraud detection can be from ATM, fraud detection can be from your email, from anywhere that can be. So the nature of data is changing, the rules of the talks are changing, right? The nature of the data keeps changing and the program needs to adopt. Again, like energy demand forecasting, the nature of data keeps changing, demands are increasing day by day. Shopping trends are also changing. 10 years earlier there were different shopping trends, and now after 10 years there are different shopping trends. So we require some kind of model that which can be updated based on the data. Okay, what challenges, whatever we discussed in previous slides, what challenges will, outcomes of the challenges will be here. Data comes in all the types and sizes, so there is not a fixed kind of data. First of all, pre-processing your data might require specialized knowledge and tools. As I told, we have to do pre-processing also on the data which we are getting. So pre-processing, like removing noise from that, filling missing data, removing spikes. So lots of things can be which we require to do a pre-processing in data. Okay, it takes time to find the base model to fit the data. As I told, there are different algorithms, right? So which algorithm will be a best for your data? So that is also a big challenge, that which algorithm, selecting the best algorithm for your data. Okay, okay, now on machine, if I am talking about machine learning, how it works with MATLAB. So these are the workflow which you see in the left side, this one. Just hold on, just 1 minute. This which you see, these are the workflow of, this is the workflow of machine learning. First of all, we require to prepare our data. After preparing a data, we require choose the algorithm. Means I am going to use support vector machine, or I am going to use Neve, or I am going to use random forest method. There are different machine learning algorithms. Okay, after choosing the algorithm, we fit our model. So you see, for preparing the data, we have an inbuilt function in MATLAB that is called CB partition. Okay, choosing the algorithm and fitting the algorithm, we have this fits in for that. Okay, so if you are choosing, see, simple, it is very simple to create a machine learning model in MATLAB. Fit C will be common for classification. Further write the algorithm abbreviation there. If I am using Neve, so I will use NB. If I am using K nearest neighbor, fit C KNN. Okay. Next is to evaluate your model, means to calculate the loss from that. What is the accuracy of your data? Training model. Okay. If you are not happy with it, then update model again with some parameters or with new algorithms using the same function that which I am talking about. This one. Okay, using the same which we used here. If you are not happy with it, with that losses are coming more, so you can, like if I am talking about nearest neighbor, you can increase the number of neighbors in that case. Okay, when you are happy with it, the final decision is make the prediction, and based on the prediction you are going to take decision on that. That's all. This is the workflow, and these are the functions in MATLAB to use for machine learning. Okay, statistics and machine learning toolbox supports several classification methods. Their performance varies for different type of data. So in MATLAB there are different kind of algorithms. You can choose any one of them, or you can try one by one on all algorithms. Okay, so in this section we will focus on the fitting and modifying the data. Fine. So how you are going to run your machine learning model, how you are going to train a machine learning model. So this is the function here which you see, this one. This is a model name. Your model name can be anything, depends on you what you are going to give your model name. And as I told, this will be same for every kind of algorithm which you are going to use, fit C, and this will be changed. This is a K nearest neighbor. If you are using support vector machine, then it will be SVM. And further, what is this? This is your table. How your table will be? This is your table. Means last will be response and remaining will be predictors. Predictor means input. A response will be your last column will be a response, that will be output. So we are going to provide this table as an input in this function, and here we are going to tell this machine learning that what is the output. Output means what this column name, what is the name of this column. That's all. In a single line you can create a machine learning model in mind. So next we are going to see how to create a machine learning model. First I will show you, next you are going to do on live data. Okay. Now further providing the property here, see here how it works actually. This is a function here which we provide. This is the function feed C. Then what algorithm are you going to use? We saw this also, table, right? We saw this also. This is the output from the table. Then these are the properties names, and here you have to provide the property value. If your model is not coming, then what property you can give manually, or what property you can optimize to get the best fit. Like if I am talking that I want to give a property name that is cost. Here you see this is the cost which I am going to give, and this will be a cost value. So this is the property value. Okay. Okay, let me switch here in MATLAB. If you have opened MATLAB online, you can open MATLAB online as well. Okay, so first of all, see here, if I type feed C, lots of algorithms are available there. I can choose any and try on any one. Okay, if I type fit R, C is for classification, R is for regression. So you see that there are different algorithms I can choose for that, right? Fine. So let me create a simple machine learning model. How to do it? First of all, if you want, you can do with me on MATLAB online. I am going to load data. So if you are doing, let me know that you are doing with me. I am going to load this mat file, .mat file. Okay. So you can load in MATLAB on MATLAB online also here. So in a minute you can create your machine learning model, and further I will show you some advanced apps that how you can choose the best algorithm for your data. Okay, so if you have opened, simply you have to give command here load. So it is still opening. Let me close this first of all. So this data I am going to load. If I run this on online MATLAB, I will get all this data. So these are actually vehicles data. Like I have a vehicle acceleration, vehicle cylinder values I have, how much I am going to displace my vehicle, that data we have. To total number of samples for every predictors we have 100, right? 100 of those are there. Horsepower available, model number of vehicles are available, from which year this model is, that is also available. Times and weight of vehicles are also available. Means what weight are you going to put and what is the weight of the vehicle. Okay, so this kind of data are available here. So your first step is to create a matrix or table. So depends on you. So in regression always use, in classification always use data as a table. If you are doing regression, you may use matrix also, means numeric matrix. Okay, so what I am going to do, as mentioned in this, I am going to create this. I will not create as a table, I will create as a matrix. Last will be output and remaining will be input. Okay, let's say that I am going to give a name car data. That's the car data. So to join multiple variables in a single matrix, we use a square bracket, like here I am using. Let's say first I am going to take acceleration, then I am going to take weight of the car, acceleration which I am giving to the car, and the weight which I am putting on the car, you may say. Okay, further I am going to take displacement. Fine. And last I want to predict mileage. So if I know the acceleration of car, if I know the weight of car, if I know that how much car is displaced, I want to create a predictive model to predict the mileage per gallon. Okay. So now I have this matrix. I require this matrix to train my model. Okay. Have you done this? Are you done? Are you doing? Are you doing or not? You can reply me on chat box if you have MATLAB and okay. If you have any issue, you can tell me. So you are going to create your first machine learning model. Okay. So this is done. See, you don't have to write all letters. Just use the tab command. Write few letters. Use the tab command because it will accept the variable from this workspace. Okay. So let me explain what we are going to do. Let's say we know the acceleration of the car. Wait a minute. If you know the acceleration of the car, if you know the weight of the car, if you know the displacement of the car, that how much it is displaced, we are going to create a predictive model to predict the miles per gallon. That is a fuel economy which we are going to predict. First we will create a model, then we will give a new value and it will predict for us. Okay. This is done. It has been done or not? Okay, next what we have to do. So here you see mileage is a numeric value. So this is a part of a regression, not a classification. So this you got, right? Because mileage here you see that is a numeric value. If I open mileage from here, this mileage, it's taking time. So you see here, these are the numeric values. These are the mileage which you see here. That is a numeric value, right? To save your data, you can use live script. Don't use command window. In command window, your code will be not saved. So better use the live script in your case. Okay. Now we are going to create a predictive model. So where I am going to save my model, I am going to give a name my model is equal to, as I told, we are going to use fit will be common for all. Now depends, I am going to do regression or classification. So we are going to do regression, so R. Now I will see here options came here, that what regression we are going to choose. I am going to choose regression Gaussian process, fit RGP. That is a regression Gaussian process that is based on the Gaussian equation, if you know. Okay. Here, what will I provide here? Okay, one thing we can do, because you see here that this is matrix, right? This is a numeric matrix, not a table. So do one thing, call from the history. See, we are not using as a table, right? So call from the history, just remove this mileage from here. We require a separate matrix for predictors and separate matrix for output in this case. But if it was a table, I will show you how to do using table as well. So don't worry about that. I will show you how to do using table. So first of all, we are doing by a matrix. Okay. So this is my car data that are predictors. Okay. Now mileage already we have here. So we are not going to create this mileage again. Now further, my model equal to, we will use fit regression it is, and we are going to use regression Gaussian process. In bracket, I am going to use car data, that is my inputs. Okay. What is the output? That is mileage, MPG. Inputs, and this is my output. Now I am going to enter. It will give me a, see, my model is created. So this is a structure. So you know how to create a structure, right? Any question from any side? Okay, done, good. So see, we got my first model. You got your first model as a my model. Whatever you gave your model name. So we have this now predictive model. Now 3 inputs you have to provide. It will predict mileage. Now we have this predictive model, right? So if I have to predict on new data, check here. If I have to predict on new data, what will I do? if you remember, predict and your model name, whatever model you created, okay, my model, and provide three inputs. Three inputs are what in our case? That is acceleration, weight and displacement. So let's say acceleration is 40, weight is 3000 and displacement, let's say it is 300. So if a car acceleration is this, car weight is this and displacement is this, then what will be a mile? Mileage, that is 22.3442 miles per gallon. So you got that is very simple. It is pretty simple here to do this task. So first of all, we created a matrix here, this one for predictors that are inputs. Then my model is equal to fit RGP. Here is the car data, that is inputs as a matrix, and this is the mileage. We created a model here as a model. This is as an object where what kind of inputs we are giving, what properties are of this regression Gaussian process, everything is given as a structure here, and we are using this my model to predict on new acceleration, weight and displacement data, that what will be your mileage. Further, what you can do, you can interface with live data. If live data are coming, just provide inside this model name and it will forecast. Are you done? Next, I will show you how to create a table and do using a table. Here you see that these are matrix. If I give a command whose and this car data, okay. So it is, see, this class is double precision floating type and it is a matrix actually. See, 100 into 3 matrix we have, right? Good. So now you are a data analyst, you are a data scientist, or you may say data engineer. You got your first machine learning model, right? Okay. Now how to use as a table. What we can do, we can create a table. Let's say that I am giving a name car table. If you have a data in a table, then how you are going to use that, I am going to show you. So remember that to convert any variable as a table, we are giving table command, and first we have to give the input, right? So first I am going to take this acceleration, then I am going to take displacement, okay, and third one I am going to take weight, and last will be in table. Don't forget to provide output, so you have to provide the output also. Last column will be output, okay. So now if I run this, I will have a table as a car table. So you see here a car table is created in your workspace here. This one, this is a table, this is a table. So you see that first is acceleration, displacement, weight, and last is the mileage, right? I am going to close this from here, close car table, okay. So now we have table, and same algorithm we are going to use. My model is equal to, let's say my model T I am going to use. So it says that it is a table. My model T is equal to fit, this is regression, so we will use R, okay. Further I am going to use again regression Gaussian process. Here I will provide my table name, the table name which we created here, car table, right? Car table, and here in a double inverted comma or single inverted comma, you have to provide what is the output in your table, that is MPG. See here the last column name, I am talking about last column name. So you see that last column name is MPG, right? So this is my output. So now if I run this, I will get again my model. If you are using regression, you can use as a matrix, numeric matrix, or as a table also. So this is my model here. But here you saw in this one, we were providing a numeric data to predict it. We were providing numeric data to predict. Here we will provide as a table. You can't provide a numeric data because your input arguments are as a table. So what we can do here, you may not do, just I am doing it. What I am doing, I am just selecting these three, right click. Okay, here option is not coming. Okay, leave it. So what you can do here, let me close this first of all. Okay, this is my model table, and what we have to do first of all to predict, we will give a predict command, right? After predict, we will give the model name, my model table, and the table name. Table name is in our case car table. It will predict on all predictors which we have. See, this is the predicted mileage on all samples which we had. Predict my model. So if you are using your input as a table, then your this new data will be also as a table with the same column name. Always remember. Let me know, did you create this table? First, next I am going to show you how to select the best algorithm for your data. So for this you require to create a table. If you want to know which algorithm will be a best for this data, so I request you create this table first of all. When you are done, let me know. I am going to use app. That app will tell me that this algorithm is the best. So first create this table. Have you created? Have you created this table? Okay. Now what is the next step? Click here in app. Click here in app. See here what I am doing. Click here in app. Click here. In machine learning and deep learning group. Okay. Here. This one. In machine learning and deep learning group. From here what we are going to do, we are going to open this regression learner. Again I am repeating, you have to go on app tab. From here just maximize. Next you have to go in machine learning and deep learning group. From this group you have to open this regression learner. Okay. Our app will be opened like this. Done. This app is open. App is open. You have to go in an app. From there you have to go in machine and deep learning group, and from there you have to open this regression learner. Okay. Okay, fine. Now click new session. new session, okay, from here, and select that table which you created. Select that table, you have to click new session and select that table which you created. In my case, I use car table, okay, this is the car table. So you see here that the blue ticks, these are predictors, and which is unticked, that is the outputs. Don't tick this, leave it as an unticked because it is output, okay. So you are a beginner, so I am not going to explain this cross validation and hold out validation. Later if you want advanced, then you can go and check what are validation. Validation is basically the way you are going to test your model. Not creating a model is only not important, validation is also important, okay. So okay, when you have done this, you have to click here start session, okay, here, this one, start session, here you have to click. Fine, I am going to click start session. Okay, now this is the session where I am going to choose the algorithm. Now you see here, if I click on this arrow, you see lots of algorithms are there. I can choose any algorithm and train, like linear regression, regression trees, support vector machines, Gaussian process, ensemble methods. These different algorithms are there. So we have either I can choose any one of them, or I can choose all quick to train or all. If I choose all quick to train, it will train on that algorithms which are supported for my data and which are faster. If I choose all, it will train on all which are slower, which are supported and which are not supported. It will let me know that which are supported or not. I am going to choose all, you also choose all, and click train. So one by one it will train on all algorithms, and it will let you know which algorithm is the best. So whose root mean square error is less, that will be highlighted here. So right now you see that SVM has a lesser root mean square error if we compare with others. If you have done, then let me know. Are you done? Let me know. If you have any questions, if you are facing any issue, then also let me know. You saw that all training is done and we got the root mean square error. If I compare root mean square error, that SPM has a lower root mean square error than other algorithms. So this is the best algorithm. That is a non-linear SVM, quadratic it is written, right? And these are the errors you see here. Blue one is measured data, observed data, and yellow which you see that one is predicted one. So here you can select. On y-axis you have output, on x-axis you have inputs. You can select any input like this. So it is showing you observed and predicted. Are you done? Any issue? So either you can do it by writing a command like we did before, or you can use this app to select the best algorithm. So here what I did, from here I selected all, then I trained here and it is highlighted. This is the best model. Okay, next what you can do, you can generate a code for that, for this if you want. Okay, here code generation option is not on MATLAB online, but you can save it as a model. So next, the model which we created by command, from here also you can save this model, export model. If I click export model, it will ask that what will be my model name. So I can rename it. I am going to give my my model name here. Okay, my model name. Okay, what you have to do after creating a model, select the best one from left side and go here in export model and select export model. When you click on this, it will give you a name and it will be saved. Now I am going to close this app. And you see that in workspace I have that model. See my model. And you can use this model. If I give just simply my model name, and it will show me that model. And now if I have to save this model, simply yesterday I told you how to save any data. No, day before yesterday, save and your file name. Let's say that my reg model. Okay, and what I am going to save, what you are going to save, just write the name here, my model name. So if I give this name, save my reg model and my model name, this is the variable which I am going to save here. Okay, the model which I created, if I enter this, you will get as a .mat file here, my reg model. So whenever you open the MATLAB, you can load that model and you can run it again from here. You see this model is saved here. So like this you can save it here. Any questions? Just ask me. Opening parallel pole. Are you doing on desktop MATLAB? Okay, if it is opening parallel pole, it will take a little time. Okay, that's why there is an option of parallel computing. So what it will do, if you open a parallel pool, let me tell you, that is a parallel computing. So let's say if you have 4 cores in your machine, at a time it will be trained on 4 cores. It will be trained on 4 cores. You will see that 2-3 algorithm will train at the same time. So it will take a little time to open that parallel computing. No problem. If you are done, then let me know. If I open desktop MATLAB from here, that same regression learner, you can choose from desktop MATLAB also. There you will get a parallel computing option also. You have to deselect that. You can use parallel computing when you have a big data. Good. So now whatever data you have in your table, you can load in MATLAB by using import tool, right? And you can train a deep machine learning model for that, right? Okay, next we are going to create a forecasting model on live data. As I told, you have, see this, here is my thing speak. We are not going to use our channel because in your channel no data is logging there, right? So what we are going to do, we are going to use some other channel where live data are there. Okay. So what I am going to do here, if you remember previously when we are creating an equation between temperature and humidity, if you remember, open your live script and here we are going to create a forecasting model. Open the live script, use the thing speak command, this, to read live data from this channel of 1 day. Num days 1 from field number 4. Why from field number 4? Because we are going to log temperature data as a Fahrenheit. Okay, when you are done, then let me know. Then later we will discuss how to create a forecasting model. Just in 2-3 lines you can create a forecasting model as well. Let's say if I know the present temperature, I can predict what will be a next temperature value, or I can predict for next 24 hours as well. Depends. If I run this, it shows temperature with respect to time. So what I am going to do here, I am going to create a forecasting model and I am going to predict for next hours that what will be a temperature in next coming hours. Okay, have you done this? If you are done, then let me know. Okay, next after executing this, go here in section break, select here. Let's say that I don't have any section here. See, my cursor is here. Okay, now my cursor is there, just I am going to click here section break, because I don't want to run this section again, so I will get the next section. After doing this, let me show you temperature, how to create a forecasting model using machine learning. That is very important. See here, this is my temperature. See what it shows here. This is the present value 61.10 on first time step. On this first time step, what is the forecasted value? Again 61.10 till here. Now you see, this is my present state, 61.100 present temperature value. So on this, what is the forecasted value? That is 60.9000. Okay. Now you see, 60.9000 is my present value. What is the forecasted value? 60.7000. So what we will do, we will create a two variable, one present state and another next state. So you see that there are repeated values. We have to remove these repeated values first of all. Okay. Or you may keep it, depends on you, if you want to remove or keep it. So we are going to keep it, leave it. If you have to remove repeated values, there is a unique command in MATLAB, unique. So all repeated value will be removed. So we are going to use this. So what we are going to do, as we know, if we have to create a forecasting model, so we know that present value is 61.100, and next value is this. Now this will become present, then next value this will become present, then next value this. Like this we have to create a two variable. Hope you got what I want to say. So here what I am going to do, let's say I am going to create x temp, means that is input, is equal to, from this temp data I am going to take from 1 to, you remember first session how we are extracting data from matrix? Same I am going to do. Int -1, last I will leave it because last will be a next value. Okay, this will be my input, 1 to int -1. This will be my input. Now what will be x? Next temp out. I am going to give a variable temp out. What will be output? Temp from index number 2 to int. Right? So whatever first value is here, on first second value will be output. On second, third will be output. On third, fourth will be output. Okay. See, I told that machine learning works. How you are going to teach it depends on you. As you teach, same way machine learning will perform the task. Okay. Let me run this. And here you see that I have two variables as a temp out and xtemp. Xtemp is the input. Let me open this variable and let me open this this temp out also. Okay, I am going to close this. So you see here this one. This is input on 61.100. My output is also 61.00. But you see here it's 61.100 on fourth row. 61.100. What is the output? Next will be output. See 60.900. That is the next here, right? If you have any doubt, you can ask me. What we are doing, we are just creating one more matrix one time ahead, one time step ahead. So here we are taking 1 to int minus 1, we are leaving 1, and in this case we are starting from index number 2 to int. The size will be same of both. Have you done this? Or if you have any doubt, you can ask me. I can explain again. So my machine learning will learn like this. The present is this, the next is this. Next will become present, then it will predict next. Then that next will become present, then it will predict the next time step. So like this machine learning will learn. Done? If you are not done, then let me know. कोई क्वेश्चन है आप पूछ सकते हो. अगर कोई भी डाउट है आप पूछ सकते हो कि फोरकास्टिंग मॉडल कैसे क्रिएट कर रहे हैं. Okay, now we are going to create a forecasting model for that. So again here you see my cursor is here and I am going to break it as a section. So you know how to run this section. You have to just click on this blue strip or just click here run or run section. Run or run section, whatever, which section, choose the section and run the section. Okay, or you can click this blue strip. Now we are going to create a forecasting model. So I am going to give a model name. My forecast model is equal to fit, and this is a regression R, and I am going to use regression Gaussian process again in this case. Okay, now I will provide the input is this, and comma output is this temp out, the next time step, right? On every input next time step it will become. Now I am going to use the semicolon here. I don't want to see the output of this model, just I am going to run this. I will click on this blue strip here in the left side. Okay, now my model is ready. See here, my forecast model is already here in workspace when I execute it, right? So when I run this, I will get that forecast model. That is the forecasted model which you see. Now we are going to this. We are going to use this forecasted model to predict on new temperature data. I am going to enter. I am going to break it as a section. To forecast on new data, let's say it is predicted value is equal to, what will I do? Predict, right? Predict in bracket model name as we are doing before, my forecasted value, and I am going to take last value of this input and I am going to predict next. I am going to take a last value of this value. I am going to predict the what will be a next temperature on next time step. So what will I do? xtemp in bracket end means last one, and when I run this I will get the next value. Now further, whatever this value came here if I provide this, here if I provide this here as an input, what it will do, it will predict the next, and it will be saved again in the same variable. So like this, what it is doing, it is predicting on the last value, it is saving the next value on the same variable, and where I run in multiple times I will get here different values, right? Now I am going to do a section break here. Next step, I am going to predict for next 20 time 200 time steps. I am going to predict next 200 time steps. So what I am going to do here, last value I am going to save here from my input, that is xtemp. Okay, this is my last value here. What it will do, it will extract the last index value by giving this command. So here I have the last value. Now I am going to use for loop. I am going to predict for next 200 steps. So what will I do? For I is equal to 200. Okay, now I am going to predict well is equal to same. I am going to copy this same thing here. So when I is equal to 1, it will predict on that value whatever the last value is there. So last value is this, right? Last value is this. So I am going to paste it here, and it will save again in this last value. What is happening? First of all, I extracted the last value. When I is equal to 1, last value will go as an input, it will be predicted, and it will be saved here as a last value. Then again this last value on I is equal to 2, it will become input, and again it will save it as a last value after predicted. Okay, so here I am going to save this data also. Print data I is equal to this last value. So what will happen in this case? Let me explain this code again. First of all, I extracted the last value from my input. I am running for 200 iterations, means for next 200 time step if I have to predict, so I am going to run for 200 iterations. Okay, now what is happening here? Predict, model name, and the last value. It will predict the next value. Next value when I is equal to 1. When I is equal to 2, it will become, again the predicted value will become as an input, then it will predict again here. And in every iteration, my data will save here as an index. When I is equal to 1, then predict data, index number 1, my predicted value will be saved. When I is equal to 2, this value will be changed, the next data will be saved. When I is equal to 3, the next data will be saved. Like this data will be saved here. When I run this, now we have, see, this is the predicted value. So you see that there are difference in points, right? And if I plot this print data, and the plot will look like this. This is the predicted value. Predicted means this is the forecasted value for next 200 time steps. Forecasted value for next 200 time steps. Any question? Any doubt in this? This is the code. When you are done, then let me know, or if you have any confusion how to make a 2 section. Someone is asking how to make a 2 section. I am not getting what section are you talking about. This is the first section here, no? This is the input and this is the output. What I have to create one time step ahead output. So that's why I took this input from one index number to end -1. Last one I am leaving it. output will be the next time step, so I am taking from 2 to end, and then I created my model here and I predicted on the last value. Further what I am doing, I am predicting using this code for the next 200 time steps. That's all which I am doing here. So whatever last date was there, it is predicting for the next 1 hour around, 1 or 2 hours, depends on the time step when data is uploaded there. What is the time step for the data? And I am plotting it, and after plotting, this is the forecasted value which I am getting here. Any question you can ask me? If you are not getting on any line, if you have any issue on any line, still you can ask me. Should I wait or go for next? Are you done? Okay, next we will see how to create Android apps. Okay, so to create Android app, just go here in new and open this. Just wait a minute, let me close this. Okay, I am going to close this. Should I close this live script? Should I close or not? Okay, I am going to close this. Now we are going to see how to create an app. So in that case, what you have to do, click on new and click on this app. New and this app. Okay, here from here I am going to create an app, new, and I am going to create this app. A new window will be opened like this. When you click here on new and this app, we are going to design an app. So I am going to design that app on desktop MATLAB. So I will show you how to create a .exe file also from that. Okay, I am going to create a .exe file also from there. Fine. So what you have to do, you do here, and I am going to do here in desktop MATLAB. So you will see how to create a .exe file also from there. Okay, because on MATLAB online we require a MATLAB compiler. MATLAB compiler right now you can't access on MATLAB online, so we can't create a .exe file. So from new you have to open the app, In your case, new browser will be open. What is the agenda in this app? What we are going to do? I have to click the blank app and a GUI will be open like this. What we are going to do? We are going to plot two equation. And from thing speak, if I give value 1, then first equation will be plotted. If I give value 2, then second equation will be plotted. If I give value 1, then first will be plotted, and if I give value 2 on thing speak, then second value will be plotted. So we are going to connect our this app through thing speak. Okay. If you are doing with me, just do. What I am going to do, first of all, I am going to drag this axis where I am going to plot. Okay, this is the axis where I am going to plot. If you want to do with me, you can open your thing speak also. Next, I want one push button. So when I click on this button, so the code will be executed. Okay, to write a channel ID, from here you see I am going to take edit field. One for channel, another for to give the value on thing speak. 1 or 2. Okay, 3 buttons I have here. 3 these buttons and 1 this push button and 2 edit field we have and 1 access we have. Okay, so now I am going to modify this button. Just I will select this. In right side you will see that what button name you want. Just I am going to write here click. Also here you see I am going to make it as a bold and I am going to change color as a green. This is the window app how you are going to create. Okay, now this is channel, so I am going to rename this as a channel. Okay, also I am going to change the color of this also. I am going to select this and I am going to change the color. So I am going to change color as yellow color, let's say. Okay, this is input, means we are providing data from here to thing speak. Also I am going to change the color of this also. I am going to change color as yellow for that also. Okay, we have this channel input and this is my access. Now one thing you remember, this channel is as a structure and channel name is app.channelEdit field. Same for the input. Here in right side you will see that is the name app.inputEdit field. So we remember that from structure how we are extracting data. So whatever value I will give, it will be saved like this, app.channelEditField.value. Same for input, app.inputEditField.value. Whatever value I will give you. Okay. Now I have to write code just below this callback. This on click callback. Okay. I will right click and from here I am going here add push button function callback. Okay, when I click on this, it will redirect to code view. So you see that this is the design view, and when I click here, there is a code view. So first of all, I am going to read the channel. So what will be channel? Channel is equal to, it will be saved here, app.channelEditField dot, remember V will be in a capital. Okay, so here I am extracting the channel number. Next, value from here. So what will I do? Let's say that thing, just I am going to give a short name. Thing value is equal to app dot input edit field dot value. Okay, from that edit text we extracted channel and thing value also. Fine. Now what I am going to do here, if thing speak, no, one thing more we are going to do, to write on that channel, right? We have to write on that channel also. So to write on channel we use thing speak write channel ID. So here I will get the channel ID from here. So thing speak write, and here I am going to provide the channel ID. Now we require a write API key, right? If you remember, write API key we require. So write API key you can get from your channel. So if I go here in API key, I will get the write API key from here. This is the write API key. Okay. Before this, what I am going to write, this thing speak value. Okay. This thing speak value I am going to write this. Sorry. Just simply I have to write here thing value. Okay. Now write API key. So write API key will be this. That's all. So what will happen when I click on this? This will be executed. This will be executed, and whatever value I will give in this edit field, that will be executed. Means if I give value 1, then I will get here value 1. Okay. Okay, now I am going to write a equation. Next I am going to write a equation. So let's say x is equal to, I am going to give some value from here. First of all, x axis value which I am going to give. Let's say it is start from 0, step size is 0.01, and it will be till 20. Now my equation is this: sine x plus x, that is a array power. So dot cat x square plus 3 into x plus 25. This is my equation, first equation. Second equation I will write direct there. So if thing speak read from this channel, this. Okay, if thing is speak read from this channel is equal to 1, then plot x comma y. Good, we are going good. If thing speak read channel value is 1, then it will plot this one. Else or we can use else if thing speak read channel is equal to 2, then plot peaks 5. This is an inbuilt function in MATLAB to plot a peak. So that inbuilt function I am going to use. Done. Further, what I am going to do here, I am going to add a LED also. If on thing speak value is 1, then green LED will glow, and if thing speak value is 2, then red LED will glow. That also I am going to do here. So I will go in design view. I will add 2 LED from here. Lamp. One lamp is here and another lamp is here. This is lamp 1, this is lamp 2. Now I will go in code view. So what will I do? If thing speak read from this channel value is 1, then what LED will glow? So what is the LED name? app.lamp. So app.lamp.color, because here we are assigning the color. What color? Green. Now in second one, app.lamp color. What color will be in this case? Red. If think speak value is 2, then color will be red and this will be plotted. If think value is 1, then color will be green and this will be plotted. Let's check that if we have any error or not. No news means good news. No error means good. So first of all, one thing more here. As I told, in a free version of ThinkSpeak, after every 15 seconds data will be uploaded. Remember. So what I am going to do here, just below this push button, I am going to pause for 15 seconds, because frequently if you send data, you will get an error. Okay, pause 15. See, step by step we created this 10 to 15 lines code. So let me do one thing. What I did here, what I have done here. First of all, I chose all these buttons which I required, all this library. This is the channel where I will provide. This will be my input data which I am going to write on ThinkSpeak, and this is a click button. When I click on this, then this will be executed. Two lamps are there. If ThinkSpeak value will be 1, it will glow green. If ThinkSpeak value is 2, then it will glow as a red. Now further, right click and I visited here, go to push button of callback. Okay, and here I wrote pause 15. Then I am extracting the channel data, extracting the ThinkSpeak value data from here. ThinkSpeak write this data I am writing here on my channel, whatever channel number is there, and write API key. Further, I created one mathematical equation. If ThinkSpeak read channel value is equal to 1, then green LED will glow. This is the structure. Everything will be saved as a app. Here it is given, so you don't have to remember anything. Okay. Then plot XY. Else if ThinkSpeak channel is equal to 2, then LED will lamp will glow red and it will plot the peak value. Okay. So instead of plot, this is a 3D plot. If you remember, we use surf for 3D surface plot, right, in first session. So I am going to do a surf of it. Now I am going to run this. It will ask me to save. Let me replace this. A new, see, this is the app. First we are going to check that if it is working perfectly or not. So first of all, here I have to provide the channel ID. So from here we can get this channel, and this is my channel ID. Now here input I am going to provide value 1. So this one value will go where? Here. Right now we don't have any data. Let's check. So after 15 seconds, that data will be uploaded here. Okay. So it will take 15 seconds to upload data there. Still, see, this plot came here. Okay, one thing more we forgot to do there. This plot is coming in a different figure window. It is not coming here. So one thing we missed it. So this is the way. First we are going to check it. If it is working fine, then we are going to create a .exe file. So what we forget, if you remember yesterday, we have to provide the access name also where we are going to plot, right? So here what I am going to do, the access name is here app.ui access. Here you can see right side, it is showing, right? So app.ui access. So here we are going to plot. What we are going to plot? X comma y. And in this case, this one, surface plot. So here also what I am going to do, app.ui access. So we have to define that UI access where we are going to plot it. One thing more I am going to add here. This is lamp 1, right? Let me check. It is lamp 2. This is lamp 2, right? This is lamp 2. Okay. So one thing more I am going to do. My lamp, first lamp will glow as a green and second will glow here as a red. Okay. And in this case what I am going to do, when second one is plotted, let me move, sorry. Okay, so when second one is plotted, then lamp 2 will become green and lamp 1 will be red. This I am going to do. Fine. Now I am going to save it and I am going to run it again to check this. Okay, so first of all we require this channel ID. I am going to provide this channel ID, and here I am going to provide value 1 and click, and let's see after 15 seconds what will happen here. So right now here value will be 1. See, this 1 value is there, so again 1 value after 15 seconds we will get the 1 value, and here we will get the plot. You see that lamp 1 is green, this is red, and this is my 2D plot. Now if I give value 2, after 15 seconds what we will get? Surface plot of peak equation. So like this you can create different equations also. So here right now value is 1. When we see after 15 seconds 2 value, there it will become red and this will become green, and here we will get the 3D surface plot. See, we told you there will be some mistake. See here what mistake we did here. It will be like this, equal to. It was in whole bracket. It will be not whole bracket. Thing is speak read channel, right, is equal to 2. So let me run it again, and I am going to close this app. So it is very good. It is a good way that first check it and create a .exe file of it, right? So here I am going to provide the channel, and now I am going to provide the value 2. When I click this, let's see what will happen after 15 seconds. So if you have a subscription version of ThingSpeak, per second you can upload data. But in free version, after 15 seconds you can upload data. You saw this is red and this is green. Now if I give value 1, it will become green, and this lamp 2 will become red, and we will get the line plot, 2D line plot after 15 seconds. So you see that here that value will be switching 1, 2, 2, and so on, it will become 1. See, now this is the line plot, and this became green, and this became red. So what we did here, first of all we extracted the library from here, what library we require. Then we right click and we visited here, go to click push button call back, and here we wrote equation. So as a default it takes 15 seconds to upload data, so pause 15 seconds. Then from edit field value, app.channel edit field value, channel edit field is what? This one. Whatever channel number is there, we saved it here as a channel, and whatever we are writing on ThingSpeak, we saved it here. Then ThingSpeak write with the data which is here in this one. The data which we are providing here, we are writing on ThingSpeak. Now we created a mathematical equation. If ThingSpeak channel is equal to 1, then lamp 1 will become green and lamp 2 will become red here. Okay. Now plot this equation which we created. Else if ThingSpeak read channel is equal to 2, if the value is 2, then lamp 2 will become green and lamp 1 will become red, and the surface plot of that inbuilt function MATLAB, that is a peak. Okay. Now next part is how to create a .exe file. So that's very simple. If you have a desktop MATLAB, just go in share. 3 kind of app you can create. MATLAB app, if I select MATLAB app, so what kind of app will be created? This kind of apps. You can deploy your app inside the MATLAB. This kind of app which you see, this kind of app you can create and deploy it here. Okay, that is a MATLAB app. Second kind of app which you see here, that is web app. Let's say that if you want to host your app on browser, so it will create a .ctf file for that. That will be a web app. So if you want to host your app on browser, and if you want that your colleagues will open that app on website on browser, you can share the link with them. That is a web app. Okay. And if I choose a standalone desktop app, it will create a .exe file for me for window app. You can create Mac app also, you can create Linux app also, depends. I am going to create a window app because my MATLAB is on window. Okay, I am going to choose a standalone desktop app, and here you can provide some photos also. Let's see, I have some photos here. I am going to provide this photo picture, data analytics on live data. This is the logo. Here you can provide your author name. I am going to provide my name and email also, company name, summary and description, depends on you, whatever you are going to provide. Next step is very important. To run Java application, you require a Java runtime. To run C application, you require a C runtime compiler. For MATLAB, to run MATLAB application, we require a MATLAB runtime. MATLAB runtime is free. MATLAB compiler runtime is free. Anyone can install it. Here is the option here. Only one time you have to install the MATLAB compiler runtime. You can get from MathWorks website. Once only you have to install. Runtime downloaded from the web. So in this case, it will create a app. When you open that app, it will check that you have a MATLAB compiler runtime or not. If you don't have, it will install it first. Second is runtime included in package. So I have already installed. If I select this one, it will create an app with runtime. So I am not going to choose this because I have already installed. Now I will click on package. So it will take a little time, 1 to 2 minutes it will take to create this app as a .exe file. And you can share this .exe file with anyone and anyone can access that. So this and this app which I created, it is an IoT app. This app is controlled by the IoT, right? Meanwhile, if you have any questions, you can ask me in a chat box. Try it. If you have issue, you can check my recorded video again, and still if you are facing any issue, you can email us too. So as I told that first time when you create, it will take a little time. First it is creating a binary of it, then it will package that app as a .exe file, and further it will deploy it in a folder. So binary means it is converting in a machine language. So it is done. See, this is the app. So 3 folders I got it. See, what is the first folder for edge distribution? So if you click this one, it will be installed on your desktop and you will get an icon. Okay. And this one is for testing. You don't require to use this one. You can use this. This will not install, but you can execute this app if you have a MATLAB compiler runtime installed. So you see, this is the icon which is opening here. And first time it takes a little time, and this app will be open, and you can share with anyone, or if you want to install it, you can install using this app. This is the app which we create. So first time it check the MATLAB compiler runtime, so it takes a little time when you open MATLAB, that app. If you have any question, just write in a chat box, or you can unmute yourself. So what we saw today, we saw how industries are using IoT with using digital twin in industries, and further we saw what is machine learning and how we can create a machine learning model using MATLAB as a prediction or as a forecasting. So we saw a regression machine learning, right? And further we saw how to extract the live data and create a machine learning model on live data as well, right? Last we saw how to create an app, and further we saw how to create a .exe file. See, this .exe file is created. This is a .exe file. I don't require this MATLAB no more. I can exit this MATLAB. I don't require this MATLAB more, because this is a .exe file. It will work as a .exe file. So here I have to provide the channel ID, and let's say my input value is 1, and when I click on this, it will be executed. After it will take 15 seconds, and here you will get the plot of that. Meanwhile, if you have any question, right now the value is not showing, you can ask me. Any question from your side? You see, this is the plot. When one thing is big, value is 1, and lamp 1 is green and lamp 2 is red. Now if I give value 2, then after 15 seconds it will give me a surface plot of that peak code, right? So that's all about the session, the 5 days workshop. Hope that you are going to learn MATLAB on RAM. So let me show you from where you will get the MATLAB on RAM. Simply, okay, you see this app is changed. Now this is red and this is green. So you can share with anyone. Okay, so just you have to search on Google MATLAB on RAM. Okay, and you can click on any link. I am better open this one, matlabacademy.mathworks.com. So lots of self-paced courses are available for you. Okay, lots of self-paced courses are available for you. Depends on you which you are going to choose. Okay, so because we have a campus-wide license, we have access of this advanced courses also: data science, programming, application development, modulation and simulation. Okay, these are the courses which are available. And from here, if you start from the MATLAB on RAM, a new window will be opened, and from there you can check that what courses are available section wise or chapter wise, and complete that. When you complete that, you will get a certificate also. So if I see, these are the courses, right? I start from here, course overview, and like this you will get the video also, explanation also, and you can whatever questions are there, you have to answer by writing a code and go next like this. After doing this, when you complete that, you will get a certificate from MathWorks like this. Like I completed MATLAB on RAM, machine learning on RAM. I completed all this advanced also, like I completed this machine learning on RAM. If I go here, so you know, if you purchase this, it will be around 6,000 around. So for you, everything is free. See, your institute is providing unlimited license with all toolboxes. If you are going to purchase MATLAB individually, it will cost you around 30 lakh, 40 lakh around as a student. So you are lucky that your institute is providing this software free for you, right? So utilize that till you are in your college, in your institute, and learn as much as possible. So this is a certificate you will get here, and you can download this certificate as well. Okay, thank you everyone for